All right, today we're cracking open the Builder's Guide to Software. We're going to take a journey through all the different blueprints teams use to create the technology we literally rely on every single day.
So, how is great software really made? It's a great question, right? We all use countless apps and websites, but have you ever stopped to think about what's going on behind the scenes? Trust me, it's not just some genius coder typing away in a dark room. It's a structured, planned, and, yeah, often a pretty complex process. Let's start with the discipline that pulls it all together.
And that discipline is called software engineering. Think of it like building a bridge. You wouldn't just start welding pieces of metal together and hope for the best. No way. You need a solid plan, you need engineering principles, and a process to make sure it's safe, reliable, and actually gets you to the other side. Well, software is exactly the same.
Okay, so here's our game plan for today. First, we'll look at what makes software good in the first place. It's way more than just code. Then we'll dive into the classic old-school blueprints, move on to more flexible, cyclical models, then get into the modern agile mindset, and finally we'll figure out how to pick the right tool for the right job.
So, let's jump right in. Before anyone even thinks about writing a single line of code, engineers have a set of core goals they're aiming for. These goals are what separate okay software from truly great software.
So what's the secret sauce? What makes software good? Well, it comes down to a few key things. Is it reliable? Does it actually work without crashing all the time? Is it maintainable so developers can easily fix bugs or add features down the road? Is it efficient? Or is it secretly draining your battery? Can it be adapted for new uses later on? And, super important, can its parts be reused in other projects to save time? These are the goals that guide every single decision.
All right, let's move on to our second section and see how all this comes together in the classic blueprints. Now, these are the traditional models, and they're all about having a very structured plan and getting everything figured out right from the very beginning. And first up, we have the famous waterfall model. Honestly, the name says it all. It's a super strict, sequential process. Each phase has to be 100% complete before you can even think about moving to the next one. And just like a real waterfall, there's no going back upstream. So here's how it works. Let's imagine we're building an inventory system for a store. First, you gather every single requirement. It needs to track products, it needs to generate reports, send alerts, the whole shebang. Then you design the entire system. Only then do you actually write the code. And after that comes testing, then deployment to the store's computers, and finally, maintenance. See, it's a very rigid, step-by-step flow.
And this visual just lays it out perfectly. You can see that clear, linear progression just flowing straight down from one stage to the next. There are no loops, no do-overs. Now, the key thing to remember here is that this approach can actually work really well if you know exactly what you need from day one.
Okay, so what if you like that structure of waterfall, but you're also really obsessed with quality and testing? Well, that brings us to the V model. It's basically an evolution of waterfall that cleverly pairs every single development step with a testing step right from the get-go. Now, this diagram, even though it's in French, perfectly shows you the V shape. On the left side, as you move down, you have all your development phases. But for each of those steps, you're planning a corresponding testing phase on the right side. So as you're designing the architecture, you're already planning how you're going to test it. It's all about building quality in from the very beginning. But here's the big problem with those classic models. What happens if you don't have all the answers up front? They really struggle with change. And that limitation is exactly why the industry started to shift. We needed ways to handle uncertainty. And that leads us perfectly into our third section, adapting with iterations. These models are all about building, getting feedback, and refining in cycles. First up is the prototyping model. The core idea here is super simple. Instead of trying to build the entire thing at once, you quickly build a working model, a prototype, and you get it in front of users. Say you're building a mobile app for a restaurant. You'd whip up a basic version for ordering, let real customers play with it, and then use their feedback to figure out what really works before you spend a ton of time building the final polished product. And you can really see that circular flow in action right here. You gather some ideas, you create a prototype, you let users evaluate it, and then you refine it based on what they said. You just go through this loop again and again and again, with user feedback acting as the engine that drives the whole process forward.
All right, next up we have the spiral model. Now this one is the heavyweight. It's designed for the really big, complex, and high-risk projects. It kind of combines the iterative feel of prototyping with the structured steps of waterfall. But it adds a hugely important new element, a massive focus on identifying and managing risks in every single cycle. And on this slide, you can see exactly how it works. Each loop of the spiral represents one full iteration, and the project literally spirals outwards as it grows and more features are added. For example, if you were building a huge new hospital system, a big risk might be data security. So in one loop, you'd build a prototype specifically to test your security solutions before you even think about adding more features. It's a very deliberate, very safe way to build complex stuff.
And that brings us to the modern philosophy that has totally taken the software world by storm. Section 4, embracing the agile mindset. Now, this isn't just one model. It's more like a whole philosophy. It's a response to a world that just moves way too fast for rigid, year-long plans. It's all about flexibility, speed, and constant collaboration. At its heart, Agile is defined by a few core principles. It's about rapid and continuous delivery, getting valuable features out the door quickly. It's about expecting and even welcoming change. It's about working super closely with your customers and empowering small, autonomous teams to make decisions, get the job done, and constantly look for ways to improve their process.
So how do teams actually do Agile? Well, two of the most popular ways are Scrum and Kanban. Scrum organizes all the work into these short, fixed-length cycles called sprints, usually 2 to 4 weeks, where the team commits to delivering a specific chunk of work. Kanban, on the other hand, is more of a continuous flow. It uses a visual board to move tasks from a to-do column to done, with a big focus on optimizing that flow and not getting bogged down with too much work at once.
And this brilliant poster, another great French visualization, by the way, it just perfectly captures the energy of this whole mindset. You see cycles, you see collaboration, continuous delivery, all of the core ideas are right there in one dynamic image. It's not a rigid top-down plan, it's a living, breathing process that adapts to deliver value fast.
Okay, so we've looked at the classic blueprints, the iterative cycles, and the agile mindset, which brings us to the million-dollar question, the final showdown. Which one is actually the best?
And here it is, all laid out. The crucial takeaway here is that there's a right tool for every single job. If your project is simple and the requirements are crystal clear and will not change, Waterfall can be simple and super effective. If you absolutely need top-tier quality for a critical system, the V model has your back. Don't really know what your users want yet? Start with prototyping. Building something massive and risky, like for NASA, the spiral model is your friend. And for pretty much any fast-moving project where changes are given, Agile is the way to go.
And that really is the ultimate lesson here. There is no single best model. The real art of software engineering is in understanding the project, the product, and the team, and then choosing the blueprint that makes the most sense for the specific situation you're in.
So, I'm going to leave you with this question. The next time you open an app on your phone, just think about it for a second. Is it a simple, straightforward utility that was probably built using a classic waterfall approach? Or is it something that's constantly changing with new features dropping every month, suggesting a more agile mindset was at work? Now you have the guide to figure it out.